Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm Victor, and today we're diving into a crucial aspect of operating system design, operating system structure. Joining me, as always, is the brilliant Sheila. How are you doing today, Sheila?
I'm doing great, Victor. I'm really excited to talk about this topic because it's fundamental to understanding how operating systems are organized and designed.
Absolutely. Let's start with the basics. When we talk about operating system structure, we're essentially discussing how the various components of an OS are organized and interact with each other. It's like the architecture of a building, but for software. Sheila, could you introduce us to the first and most straightforward structure?
Of course, Victor. The simplest and oldest structure is the monolithic structure. In this approach, the entire operating system runs as a single program in kernel mode. It's organized as a collection of procedures, each of which can call any other one whenever it needs to. Think of it as a big, single-story building where everything is interconnected and on the same level.
That's a great analogy, Sheila. While monolithic structures are simple and can be very efficient, they can also be difficult to maintain and extend. Can you tell us about some real-world examples of monolithic operating systems?
Certainly. Traditional Unix systems were originally designed with a monolithic structure. Even today, while they've evolved, operating systems like Linux still have many monolithic characteristics. The main advantage is speed and efficiency, but as you mentioned, they can be challenging to modify and debug.
Excellent point. Now, let's move on to a slightly more organized approach. The layered structure. How does this differ from the monolithic approach?
The layered approach is like a multi-story building, Victor. The operating system is divided into a number of layers, each built on top of lower layers. The bottom layer is the hardware, the highest layer is the user interface. This structure provides a level of abstraction, where each layer only interacts with the layers directly above and below it.
That sounds more organized than the monolithic structure. Are there any notable examples of layered operating systems?
While pure layered systems are rare in practice, some early operating systems like the Technische Hogeschool Eindhoven operating system used this approach. Modern operating systems often incorporate some layering concepts, even if they're not strictly layered throughout.
Interesting. Now let's talk about a more modern approach, the microkernel structure. This is quite different from what we've discussed so far, isn't it?
Absolutely, Victor. The microkernel approach is like having a small, efficient core in your building that handles only the most essential functions, with everything else built as separate modules around it. In OS terms, it moves as much from the kernel into user space as possible. The microkernel provides minimal process and memory management, along with communication facilities.
That sounds like it could solve some of the problems we see with monolithic structures. What are some advantages of this approach?
Great question. Microkernels are easier to extend, more secure, as less code runs in kernel mode, and more reliable, as a crash in one service doesn't bring down the entire system. However, they can have performance overhead due to increased system function overhead. An example of a microkernel-based OS is QNX, which is used in many embedded systems.
Fascinating. Now for our final structure, let's discuss the modular approach. How does this differ from what we've covered so far?
The modular approach is like having a flexible, customizable building where you can easily add or remove rooms as needed. It's similar to the layered approach, but with more flexibility. The kernel has a set of core components and dynamically links in additional services either during boot time or during runtime. This allows the operating system to be customized to meet specific needs.
That sounds incredibly flexible. Are there any widely used operating systems that employ this approach?
Yes, indeed. Modern versions of Unix and Linux use a modular approach to some extent. For example, Linux allows kernel modules to be dynamically loaded and unloaded, which gives it some of the flexibility of a modular system while retaining the performance benefits of its monolithic core.
Excellent explanation, Sheila. As we wrap up, could you give us a quick recap of the key points we've covered today?
Certainly, Victor. We've discussed 4 main operating system structures. 1. Monolithic, simple and efficient but hard to maintain and extend. 2. Layered, more organized but can be less efficient due to layer traversal. 3. Microkernel, flexible and secure but with potential performance overhead. 4. Modular, combines flexibility with performance used in many modern systems. Each structure has its own strengths and weaknesses, and understanding them is crucial for anyone working with or designing operating systems.
Thank you, Sheila, for that excellent summary. And thank you, listeners, for tuning in to another episode of Operating Systems Crashcast. Remember, understanding these structures is key to grasping how modern operating systems function and evolve. Until next time, keep exploring the fascinating world of operating systems.